All right, today we got trig functions of real numbers. Trig functions of real numbers. Few really important slides here. This first one says that t be any real number and that p be the point xy, be the terminal point on a unit circle determined by t. Okay, so t, some number t, I'm going to go that far, whatever t is, along the unit circle and get some point p. Now, when you get to that point has an x coordinate and a y coordinate. What I want you to get from this slide is cosine is the x, sine is the y. Cosine of t is the x coordinate, sine of the t is the y coordinate. Cosine is x, sine is y. Cosine is x, sine is y. That is so huge. Tangent is just y over x. Remember I told you earlier, tangent's really sine over cosine. And if sine is the y, cosine is the x, tangent is y over x. The other three down here, just reciprocals, just reciprocals, just reciprocals. And remember, if you have a variable in your denominator, all these things that say y cannot equal 0, x cannot equal 0, that's so the denominator is not 0. So let's review real quick. You can pick any number you want to, t. You go that far around the unit circle. When you get to how far t is, you end up at a point. The point has an x and a y. Cosine of t is the x coordinate. Sine of t is the y coordinate. Tangent of t is y over x. That is so huge. All right, there are special values that you're just going to need to know. To be honest, if you just learn this slide right here, you will have the whole entire unit circle. Just trust me there. Okay, so 0 is the point 1, 0. Pi over 6 is the point square root of 3 over 2 and 1/2. Pi over 4 is square root of 2 over 2 and square root of 2 over 2, which you should know. Pi over 3 is 1/2 and square root of 3 over 2. Notice pi over 6 and pi over 3, the x and y coordinates just switched. That's a great way to remember it. And then pi over 2, they just switched from 0. Remember, pi over 2's up here at the top of the circle, and 0 is right there. Excuse me. Also, don't forget, cosine is the x's, sine is the y's. Cosines are the x's, sines are the y. Cosine, sine, cosine, sine, cosine, sine of t. All right, so this says find all trig functions of t and gives you t is pi over 3. So what we did is we went pi over 3 around the unit circle. Remember, it's 2 pi all the way around the unit circle. It's 1 pi halfway around. And if you go pi over 3, that's the point you come to. You come to 1/2 and square root of 3 over 2. Sine is the y coordinate. Cosine is the x coordinate. Tangent is the y over the x coordinate. Right, the rest are just reciprocals. Cosecant pi over 3 is reciprocal of the sine, which you just move the radical to the top, take it out on the bottom. Secant's reciprocal of cosine. Cotangent's reciprocal of tangent, which would look like this, and then rationalize. Actually, I messed up that tangent right there. Sorry about that. This is live TV again, so I'm just going to erase those real quick. Sorry about that. Tangent is sine over cosine, which would just be square root of 3. Sorry about that. So this would be 1 over square root of 3, which would be square root of 3 over 3. What I did is I looked at sine and cosecant instead of sine and cosine. To be honest, when I'm doing tangent, I don't usually look back at the picture. I know tangent is sine over cosine, so I usually just look at the sine value and the cosine value. But I looked at cosecant instead. That's what messed me up. At least that's my excuse. All right, find all 6 trig functions of t. T is pi over 2. So we went pi over 2 around the circle, all right? Which took me halfway to pi, which makes sense. Half of pi is pi over 2. Took me to the point, whoa, don't know what just happened right there. Took me to the point, just messed up my whole slide. Took me to the point 0, 1. Okay, now here we go again. Sine is the y coordinate, which is 1. Cosine is the x coordinate, which is 0. Tangent is y over x, which would be 1 over 0, which you cannot have. So tangent of pi over 2 is undefined. It's undefined. It's supposed to say undefined. Cosecant is reciprocal of 1, which is 1. Secant, pi over 2 would be, again, it'd be putting 0 on the bottom, which you cannot have. So that's also undefined. Cotangent would be, instead of y over x, would be x over y. So it'd be 0 over 1, which is just 0. Okay, so sometimes some of the functions are undefined depending on what point you're looking at. All right, here's the chart. That chart right there represents the whole entire unit circle, really the whole first quadrant of t values and their trig functions that correspond with them. You may want to stop this video, like take a picture with your phone or something of that slide. That has every single thing. These 2 columns right here were on the first slide I showed you today. Okay, I didn't show you these because you can derive all of these answers if you know those. So the main thing are these 5 or 6 points right there. That's 5 or 6 values of t. And I'll tell you this again, if you can learn those values right there, you know the whole entire unit circle, and I'll show you that as we get closer to class. All right, here's where it all comes from. Let's say you have this right triangle, which you've seen before, and we know all the trig things, the SOHCAHTOA. Think about SOHCAHTOA. You see where theta is. Well, if I take that triangle and put it in the unit circle, like I did this right here, and obviously I'd say it's bigger than the unit circle. If I draw this side right here, I'm going to need you to remember back to your geometry days. If I draw that side right there, right, what that gives me is two similar triangles, which means all the ratios of the sides are in proportion. So trig is all about ratios, like tangents, x over, y over x, cosine is x over 1, all that kind of stuff. So all the ratios will be the same. So looking at that, what that tells me, I'm going to blow this up just a little bit. What that tells me is to get to this point, to get to my xy point, you go that far on the x, that far on your y, and then that's your radius right there, which is 1. That's just 1 because it's a unit circle. Okay, now look at my theta in there. All right, remember sine is opposite of our hypotenuse, so sine is y over 1. Remember cosine is adjacent of our hypotenuse, so cosine is x over 1, which is what this box says down there. So that's why this stuff works. It's all about the SOHCAHTOA still. So the radian measure of any angle, theta, is the same as t. Whatever t is, that's what our radian measure is. All goes back to SOHCAHTOA. All right, domains of the trig functions, sine and cosine, the domain is all real numbers. Tangent, secant, remember we said some are undefined. They're undefined at all the pi over 2s. If it's 1 pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, they're undefined there. So tangent and secant, all real numbers except for pi over 2s. Cotangent and cosecant, all real numbers except for the pi's. 1 pi, 2 pi, 0 pi, 3 pi, 4 pi, 5 pi, negative 2 pi. Any pi, those are undefined. The rest of the time, it's all real numbers. And down here tells you all about the signs. Don't forget cosine is x. Cosine t is x. Sine t is y. So wherever cosine is positive, wherever x is positive, or wherever y is positive, that's where cosine and sine are positive. So in quadrant 1, everything's positive. In quadrant 3, which is opposite of where quadrant 1 is located, everything is negative. That means cosine and sine are both negative. But if cosine and sine are negative, that means tangent is actually positive. Okay, which is because, remember, tangent, sine over cosine. So negative divided by negative. In quadrant 2, the x is negative, y is positive. So sine and cosecant are positive. In quadrant 4, you go right down, which means the x is positive. So cosine and secant are positive. Everything else is negative. All right, so big deal about knowing the signs on the quadrant, what's positive and what's negative in the quadrants. Okay, find each value. I went ahead and drew the picture for you. Down here too, the first one says cosine of 2 pi over 3. So, there's cosine 2 pi over 3. I drew it right there. I want you to do this. Even if it says 2 pi over 3, I want you to think reference angle. I want you to think, well, what is cosine pi over 3? And hopefully either from the first chart or you just remember by now, it's a half. Okay, that's what cosine of pi over 3 is. But 2 pi over 3 tells me, okay, look, I drew it right there. It's in quadrant 2. Remember, cosine is x, the x coordinate, and x is negative in quadrant 2, so cosine is negative in quadrant 2, so it'd be negative pi over 2. Negative 1/2, I mean. The second one says tangent of negative pi over 3. Tangent negative pi over 3. That's quadrant 4. That's down here, going negative pi over 3. I want you to think this way. I want you to think tangent positive pi over 3 first, and think about what that value is. Look back at the table if you need to. That value is square root of 3. All right, but because we're in quadrant 4, the quadrant's going to determine what sign I put on that square root of 3. And because tangent is y over x, and because x is positive, y is negative, one of them is negative, that means tangent's negative in quadrant 4. Okay, last one here. C, sine 19 pi over 4. Even though it's 19 pi over 4, I want you to think just pi over 4. Okay, all the pi over 4s are square root of 2 over 2. I think you know that by now. 19 pi over 4, I drew this, man. 4 goes into 19 4 times, so it's really 4 3/4 pi, and that's how I do this. I always change them in proper, which means 4 pi would be like 1 pi, 2 pi, 3 pi, 4 pi, and I got to go 3/4 of another one, which puts me right there in quadrant 2. Sine is the y. Remember, y is positive in quadrant 2, so that means the answer is just it's positive square root of 2 over 2. All there is to it. All right, remember, This is one last slide to remember what the reciprocals are. Cosecant, reciprocal of sine. Secant, reciprocal of cosine. Cotangent, reciprocal of tangent. Just don't forget those. Guys, that's quite a bit of one video. You've got to go back. You need to learn those first quadrant ones. I will give you a two good ways to do that. I feel like there are two good ways to do that in class tomorrow. But you need to learn those values in the first quadrant, because if you do, you got the whole entire circle. Just trust me there. All right. See you tomorrow.